Good morning, students. Today in this session, I'm going to explain ion selective electrode, pH determination by using Quinn hydrogen electrode, and some numericals on electromotive force. So these are the last topics in electrochemistry. After electrochemistry, I will start practice. So first let us see what is ion selective electrode. So in the name only we have that electrode is selectively passing the ions. Ion selective electrode is one which selectively responds to a specific ion in a mixture, and the potential developed at the electrode is a function of the concentration of that ion in the solution. So here whatever the electrode we are using here, that electrode is responding to the specific ions. For example, let us assume the electrode is responding to the H plus ions, and when we are taking the hydrochloric acid, it is not responding the Cl minus ions. Hydrochloric acid is having H plus ions and the Cl minus ions. But the particular electrode is able to pass or respond only to the H plus ions but not to the Cl minus ions. So that is mean by the ion selective electrode here. So when that particular ions are passing through the membrane or passing through the electrode, there develops potential. So that potential is studied in the ion selective electrode. So ion selective electrode is one which selectively responds to a specific ion in a mixture, and a potential developed at the electrode is a function of the concentration of that ion in the solution. So whatever the potential is developing here, that potential is the function of the concentration of the particular ion. That means whatever the ion is passing through the electrode, that ion concentration is relates to the electrode potential. So here ion selective electrode example is the glass electrode. So it is part of our syllabus, glass electrode. A glass electrode is an ion selective electrode where potential depends upon the pH of the medium. So here that potential is depends upon the pH of the medium. Medium is nothing but whatever the electrolyte we are using, that electrolyte pH we are calculating by using the glass electrode. So a glass electrode is the ion selective electrode where potential depends upon the pH of the medium. And the glass electrode consists of a glass bulb. So whatever the electrode we are using here, the glass electrode, that glass electrode is having the glass bulb made up of a special type of glass. So that glass is a sodium silicate type of glass with high electrical conductance. So whatever the membrane or whatever the bulb we are using here, that bulb is made of the special type of glass. So that glass is a sodium silicate type of glass, and that glass is having the good electrical conductance, high electrical conductance. And the glass bulb is filled with a solution of constant pH and insert with silver chloride electrode, which is the internal reference electrode and also serves for the external electrical contact. So initially what we have taken in the glass electrode, we have taken the glass bulb. That glass bulb is filling with the solution of constant pH. That means whose solution pH is constant, that solution we are taking in the glass bulb. And in this we are inserting silver chloride electrode. And that electrode is acting as an internal reference electrode, and it is also used to provide the electricity. It is responsible for providing electricity. And the electrode dipped in a solution containing H plus ions as shown in the figure. So whatever the electrode we are using, that is silver chloride electrode, is dipping in the hydrochloric acid solution. So see, this is the diagram. This is the diagram of the glass electrode. So initially we have taken the glass bulb. The glass electrode is consisting of the glass bulb. And this glass bulb is filling with the known pH or constant pH solution. Here constant pH solution is 0.1 normal hydrochloric acid, and placing silver chloride electrode, which is responsible for electricity, and it is dipping in the electrolytic solution. Yes, so this is the glass electrode diagram. So now let us see how to represent the glass electrode. Same like the quinhydrone electrode and the saturated caramel electrode, even glass electrode also either acting as the anode or acting as a cathode. That depends on the other electrode. Yes, so it is acting as the reference electrode, and other electrode is nothing but the unknown electrode. So what is meant by the unknown electrode? Whose electrode potential to be calculated or whose electrode potential is unknown. So we are finding the electrode potential of unknown electrode by using the reference electrode. So here glass electrode is one of the reference electrode to find the electrode potential of the unknown electrode. Yes, so it is acting as either anode or acting as the cathode. So let us see how to represent the glass electrode. Glass, because here even glass also responsible. Previously in saturated caramel electrode, the instrument, the outside glass bulb is not participating in the reaction. But in glass electrode, it is made of the special type of glass, and it is only responsible for transfer of ions from one electrolyte to another electrolyte. So here glass also placing the important role in the glass electrode. So in glass what we are taking 0.1 molar HCl or 1 normal HCl slash silver chloride electrode. So here we have taken for cathode. So for cathode, how we will write cathode electrolyte? Cathode. Yes. So here this is electrolyte and this is electrode. But for anode, how we will write? Electrode electrolyte. So what is the electrode here? AgCl is electrode and 0.1 molar HCl is the electrolytic solution. Yes. So this is the cell notation for glass electrode if it is acting as a cathode. So now let us see how it is working. So the glass electrode works on the principle that when a thin glass membrane is placed between two different concentration of a solution, a boundary potential EB is developed at the layer of the glass membrane. That means when this electrode is dipping in the another beaker, yes, so when we are taking the another beaker here, and in this beaker what we are taking the solution whose pH value to be calculated. Yes, why the glass electrode is useful? The glass electrode is useful to know the pH of the unknown solution. Yes, so what we are doing, this glass electrode is dipping in the solution whose pH value to be calculated. But when it is dipping in the unknown solution of pH, this glass membrane is separating the two different concentration of the solution. Inside we are having one solution, that is hydrochloric acid, and even outside also we are having another solution, that is unknown pH. So when this glass membrane is separating two different concentrated solution, there develops potential difference. That potential difference is EB. That is the boundary. Boundary is nothing but this membrane is acting as a boundary here. The boundary potential difference. That boundary potential difference is denoted with EB. See here, EB. So the glass electrode works on the principle that when a thin glass membrane is placed between two different concentration of the solution, a boundary potential EB is developed at layers of the glass membrane. That means at the membrane, the potential difference is arising. This potential arises due to difference in the concentration of H plus ion inside and outside of the membrane. So why the potential difference is arising? Due to the difference in the concentration of inside solution and the outside solution. See here the external solution. So where the external solution is? The external solution is present in the beaker. In this beaker only we are dipping the glass electrode. So the external solution concentration we are assuming C2, and that C2 is having the unknown H plus ion concentration. So C2 is equals to H plus ion concentration, and potential of this solution we are assuming as E2. This is a potential of the unknown solution pH value. And internal solution, we are having one solution internally. That solution pH is constant, and what we are assuming, the potential of the internal solution is even. So now this is the glass membrane. What glass membrane is doing here? So C1 is equals to constant. It must come here. That is the internal solution. And the glass membrane is developing the potential. That potential is the boundary potential, that is EB. So here boundary potential EB can be written as E2 minus E1. That means the external solution electrode potential value minus internal solution electrode potential value. Yes. So this is the boundary potential. So that means simply you remember. So when the glass electrode is placing in the unknown solution pH value, the glass membrane is develops a potential. That potential is called the boundary potential. The boundary potential is nothing but the potential difference between the inner solution and the outer solution. So now let us see the formula of E1 and E2. So already you know from the Nernst equation. What is the Nernst equation? E is equals to E naught minus 0.059 by N log K. Yes. So that is the formula of the Nernst equation. Yes. So let us see for E1 and E2. E1 is equals to E naught minus 0.059 by N log C1, because this concentration is C1, and in E2, E naught minus 0.059 by N log C2. So this is the E1 formula and this is the E2 formula. Now by substituting these two formulas in this, we will get the potential difference or the boundary potential. So where C1 and C2 are concentration of H plus ions, inner and outer membrane. Yes. So inner solution is having one concentration, outer solution is having another concentration. C1 is the inner solution concentration and C2 is the outer solution concentration. And substitute the values of E1 and E2 in equation 1. So this is the equation 1. When we substitute E1 and E2 here, we will get EV. See here, this is E2. E naught minus 0.059 by N log C2 minus of E naught minus 0.059 by N log C1. And here N is nothing but number of electrons. Number of electrons is equals to 1 in the case of any acids here. So H plus 1. So N is the number of electrons. So number of electrons is equals to 1 here. So when we are substituting N as 1, we will get E naught minus 0.0591 log C2 minus E naught minus of minus plus 0.059 log C1. So here we got minus E naught and here we are having E naught. So this E naught gets cancelled. So this will comes to the front and this will comes here. So we will get 0.0591 log C1 minus 0.0591 log C2. But what is C1 here? C1 is nothing but it is the concentration of inner solution and C2 is the concentration of outer solution. But what is the concentration of inner solution? Concentration of inner solution is constant. That is a known value, numerical, and that is a constant value. That is not variable. So we can take this part as the constant. So we are assuming this constant part as the K. So since the concentration of the inner solution is constant, so C1 is constant, but C2 what is C2? C2 is the outer solution concentration. But do we know the unknown solution concentration? No, unknown solution concentration is not known. Yes, so it is the unknown solution concentration. So what we are writing, C2 is nothing but H plus concentration. That is the unknown solution concentration. So let us substitute here 0.0591 log C1 minus 0.0591 log H plus ion concentration. But here this part is equals to constant. We are assuming that constant as the K. So we can write simply EB is equals to K minus 0.0591 log H plus ion concentration. But here the glass electrode potential is the sum of boundary potential. Now you know what is boundary potential. The boundary potential is nothing but the potential arises at the glass membrane when the two solutions concentration are different. That is the boundary potential. So the glass electrode is the sum of the boundary potential, silver chloride electrode potential, and asymmetric potential EC. Yes. So there are three types of potential: boundary potential, silver chloride electrode, and asymmetry potential. So theoretically, EB is equals to 0 for C1 is equals to C2. If C1 and C2 are equal, that means inner solution concentration and outer solution concentration are equal, then what will happen? EB will be equals to 0. Then small additional potential exists that called easy potential. So when the easy potential is arising, when C1 is equals to C2, EB will not equals to 0. There is small additional potentials are added. Those small additional potentials are called easy potentials. So we are writing as EG is equals to EB, that is the boundary potential, plus silver chloride electrode potential plus E asymmetric. But here we know what is EB. EB is nothing but K minus 0.0591 log H plus K minus plus AgCl plus ES. So here K and AgCl and E asymmetric, these three are constant. So that constant we are assuming as E naught G. That is the glass electrode potential at the standard conditions. So by adding these three, we will get the glass electrode potential at the standard conditions. So finally we got Eg is equals to Eg naught minus 0.059 pH. So this is glass electrode potential value. Yes. So glass electrode is the example of ion selective electrode. That membrane is specifically allowing only H plus ions. It is not allowing any type of ions here. Yes. So that's the reason the name of the electrode is the ion selective electrode. So now let us see the last topic in this, that is determination of pH by using quinhydron electrode. Yes. So we can determine the pH by using glass electrode, quinhydron electrode, standard hydrogen electrode. Maybe in the intermediate level you have seen the hydrogen electrode, but in engineering level that is not part of our syllabus. But hydrogen electrode is used to find the pH of the unknown solution. Quinhydron electrode also used to find the pH value of unknown solution. And now we have seen the glass electrode. Even glass electrode also used to find the electrode potential, pH of the unknown solution. Yes. So let us see here. But here by using quinhydron electrode, we can find pH up to 8 only. But it is part of our syllabus. By using glass electrode, we can find accurately pH value up to 12 or even up to 14 also. So the pH can be determined by using indicator electrode, that is the quinhydron electrode, which is reversible with H plus ions like quinhydron electrode. So already we have seen that the quin hydron electrode is reversible with H plus ions. That means when we are adding quin hydron electrode a pinch in the acid, what happens here? The quinone is converts to the hydroquinone and hydroquinone is converts to the quinone by losing or gaining the H plus ions. That means here the quin hydron electrode is reversible with the H plus ions. So we are finding the pH by using quin hydron electrode. But we know for quin hydron electrode, this is quinone. Quinone is gaining 2 H plus ions by gaining 2 electrons to produce quin hydron. And in the reversible case, the quinone, that hydroquinone is converts to quinone by losing 2 H plus ions and 2 electrons. So this is the reaction for the quin hydron electrode. But for quin hydron electrode, what is quin hydron here? Quin hydron is the noun electrode, that is a reference electrode. So we know the E naught value. Here E naught value is 0.699. So that is the E naught value of the quin hydron electrode, 0.699 volts. But we have represented quinone as Q, quin hydron as QH2. So we can write Q plus 2H plus 2 electrons, reversible hydroquinone, that is QH2. So now the electrode potential is given by E is equals to E naught minus 0.059 by N log K. So from where you got this? You got this from Nernst equation. So that is E is equals to E naught minus 0.059 by N log K. Yes. So now here we know what is K. K is products concentration divided by reactants concentration. So here E naught minus 0.059 by 2 log product is QH2 by reactant is Q into H plus power 2. Yes. So that is the products concentration divided by reactants concentration. But we know that quinone and hydroquinone, these two are in the equimolar concentration. That means these two are in the equimolar. These two concentrations are equal and these two portions are equal in the quin hydron electrode. So here quinone and hydroquinone, these two values are equals to 1. So when we substitute these two values equals to 1, we will get E is equals to E naught minus 0.059 by 2 log 1 by H plus power 2. So when it is goes to the numerator, we will get H plus power minus 2. But that is in the form of log A power minus 2. Log A power minus 2 means minus log H plus. So we can write E is equals to E naught minus 0.059 by 2 minus 2 into log H plus. Now 2 gets cancelled. So E is equals to E naught minus 0.059 minus of log H plus. But we know what is minus log H plus. Minus of log H plus is nothing but pH. So let us substitute in the place of minus log H plus pH. So we will get E is equals to E naught minus 0.059 pH. But what is E here? This is the electrode potential of the quin hydron electrode. So EQQH2 is equals to E naught QQH2 minus 0.059 pH. So now we got the electrode potential of one electrode. Now we need to know another electrode to develop the potential. What is the EMF? EMF is nothing but potential difference between two electrodes. So when we develop EMF, then only we can find the pH value. So to develop EMF, we are connecting this electrode with another electrode. So we are connecting quin hydron electrode with the another electrode. That another electrode is the saturated calomel electrode or the standard calomel electrode. But we know what is E naught. We have seen here E naught is nothing but 0.6994. So E naught of quin hydron is 0.6994 volts. So when we substitute in the place of E naught as 0.6994 volts, we will get EQ is equals to 0.6994 volts minus 0.059 pH. Yes. So that is the quin hydron electrode potential. Now this electrode is combined with a saturated calomel electrode and the cell EMF is generated. So what we are doing, we are connecting the quin hydron electrode with a saturated calomel electrode to develop the EMF. So when we are connecting, so this is the cell notation of the saturated calomel electrode. So how to write the cell notation for anode? Anode electrolyte. So here anode electrode is mercury, mercurous chloride platinum, vertical line KCl, double vertical line H plus, vertical line quinone, quin hydron platinum. Yes. So this is the cell notation. Once you go to the previous classes, you can understand well how to write the cell notation. So this is for anode and this is for cathode. So what is cathode here? Quin hydron electrode is acting as a cathode and calomel electrode is acting as the anode. But what is E cell? E cathode minus E anode. So what is the cathode here? Cathode is the quin hydron electrode. So we can mention in the place of cathode quin hydron electrode minus anode is a calomel electrode. So we can write E calomel. But here calomel electrode is the reference electrode here and the quin hydron electrode is the test electrode here. Yes, that means it is the indicator electrode here. Indicator electrode means it is not completely known. But reference electrode means whose E value already known. So we know E calomel value. We know E calomel value, that E calomel value is 0.2422 volts. But we know what is EQ. From here, EQ means E naught Q minus 0.059 pH. So when we substitute here, we will get 0.6994 minus 0.059 pH minus, when we substitute E calomel, we will get 0.2422. So, but we need to calculate pH. So the remaining values goes to the left side, or this value goes to the left side and this value comes to the right side. And finally, we will get pH is equals to 0.6994 minus 0.2422 minus E cell divided by 0.059. Yes. So this is the pH determination by using quin hydron electrode. So now let us see the numericals of EMF. So calculate the EMF of the below redox reaction. So this is the cell reaction. Now you need to find the EMF, that is electromotive force. EMF is nothing but E cathode minus E anode. So now let us break the reaction to write the reduction and oxidation reaction. Here Mg is converts to Mg plus 2, 2H plus is converts to H2. Yes. So in step 1, how we have written? 2H plus is gaining 2 electrons. Because how many H plus ions are there? 2 H plus ions. Each H plus ion needs 1 electron to get neutral. So here 2 H plus plus 2 electrons giving rise to H2. So hydrogen ion takes an electron to form hydrogen gas. And magnesium undergo oxidation by losing 2 electrons. That means Mg is losing 2 electrons to produce Mg plus 2 electrons. Yes. So in the first step, what we have done the reaction pattern. Now let us find the standard reduction potential of the half cell reaction. That means here we need to know E naught value of hydrogen and here we need to know E naught value of magnesium. That means we need to find E naught of reduction, E naught of oxidation. E naught of reduction, that means E naught of hydrogen electrode is 0 volts and E naught of magnesium is minus 2.372 volts. So how to find E naught cell? E naught cell means E naught cathode minus E naught anode. So cathode reduction, anode oxidation. So E naught reduction minus E naught oxidation. E naught reduction minus E naught oxidation. So what we will get? Finally we will get 2.372 volts. So we calculated E naught cell value. So what is E cell formula? E cell is equals to E naught cell minus 0.059 by 1 n log K, or E naught cell is equals to E naught cathode minus E naught anode. Already we found here. Yes. So this is the EMF of the redox reaction here. That is E naught cell, EMF. So now let us see the next formula, next problem. Calculate the potential of the following redox reaction. So here Ag is converts to Ag plus, Li plus is converts to Li. Yes. So what is the first step? We need to write the reaction part. So Ag is losing one electron to produce Ag plus. Li plus is gaining one electron to produce Li. That is the first step. So what is the second step? We need to find E naught of the each electrode. So E naught of reduction, E naught of oxidation. What is reduction electrode? Lithium. Oxidation electrode is silver. Lithium E naught value is minus 3.045 volts and E naught of silver is minus 0.799 volts. And what is the last step? In the last step, what we are doing? We are finding the EMF value by doing E naught cathode minus E naught anode. Cathode is this one, anode is this one. E naught cathode minus E naught anode. We will get E naught of cell. So that is minus 3.844 ohms. And the last numerical. Consider a redox reaction. This is the redox reaction. The standard electrode potential of reduction and oxidation reactions are given in the problem. That is 0.80 minus 0.40 respectively. And calculate the standard potential for the reaction. Yes. So we need to calculate the standard potential value. So we know E naught of reduction, E naught of oxidation. So here which is undergo reduction? Ag plus is converts to Ag. How Ag plus is converts to Ag? By gaining electrons only. Yes, gaining of electrons is nothing but reduction. So which is undergo reduction? Silver is undergo reduction. But cadmium is losing 2 electrons to produce Cd plus 2. So cadmium is losing electrons. So cadmium is undergo oxidation here. So consider a half cell reaction. So we know how to write the reaction now. 2 Ag plus 2 electrons to given rise to 2 Ag. That is reduction. But we know what is the reduction reaction value. That is 0.80. And cadmium is losing 2 electrons to produce Cd plus 2. And we know what is E naught of cadmium. From here 0.40. Now let us calculate total EMF value. E reduction plus E oxidation. They asked total EMF value. So E reduction minus E oxidation. What is the reduction value? 0.80 minus of minus 0.40. So minus of minus will be plus. So we got 0.40 plus 0.80. So we got 1.20 volts. So what is the total EMF of the redox reaction? 1.20 volts. So simply we need to substitute E cathode and E anode. In the external examination, they will give the E cathode value and E anode value. Just you need to substitute those values in the formula to find out E cell or E naught cell. E cell formula is E cathode minus E anode. E naught cell is equals to E naught cathode minus E naught anode. Now, thank you. So with this, we have completed electrochemistry part. In the next class, I am going to start the batteries. In the batteries, we are having only 2 to 3 topics. So we will finish the batteries in 2 to 3 classes.